Alright, so it seems like a long time ago now, grade 8s did deal with kind of an introduction to volume and said, well, if we know the area of the base, we can calculate the volume. So the question today is, well, what if you don't know the area of the base? Because usually you don't. Usually you're going to be given the dimensions of a right prism. And so the question is, how can you use the dimensions to calculate the volumes of right prisms? So now, the one thing here, with any of this stuff here, this is really important. Base of the prism must be the same side, must be the side that is the same as the top, sorry. What this means is this is not going to work for like a pyramid, right? So, we make a pyramid shape of some sort. These formulas we're going to develop won't work. There are formulas for those, but this is not going to be one of them. It's not going to work for a cone. Okay, it would work for a right rectangular prism, a right triangular prism, and a right cylinder. But that's going to be really kind of where we end, at least today. Are there formulas to calculate volumes of other kinds of 3D shapes? Absolutely. Some of them are pretty easy. Some of them are a little bit more confusing. So today, looking at this. So example number 1. All right, we've got these two lovely shapes. We've got a cube and we have a right rectangular prism. Okay, which right rectangular prism, just to get that out of the way, essentially it's a box where all the sides don't have to be the same length, right? So that the length, the width, and the height are not necessarily the same. A cube, length, width, and height have to be the same. So let's look at our formula. These are going to be important, and I'm going to make you write them down every time. All right, so right rectangular prism, volume equals length, I write it as a little handwritten L, times width times height, LWH. Real easy. You have to write the formula down. I know it's going to seem really stupid and really easy with these first few things. Eventually you're going to get to the point where you need to be able to use a formula and write stuff down. So get used to it with easy stuff so that when you get to harder stuff, you can use a formula. Okay, so here, volume equals, so length, and here it's telling us they're being quite nice to us, that length is 2. So it's 2 centimeters. And the way I am always going to write this, whether it's on a computer screen or if I'm on a whiteboard, the 2 centimeters goes in brackets and it's sandwiched right next to another set of brackets. Okay, and the next set of brackets will have the width, which is 3 centimeters. And the last one is going to have the height, which is 4 centimeters. So what this means is the volume is equal to 2 centimeters times 3 centimeters times 4 centimeters. The happy thing about multiplication is it does not matter which ones we multiply first, so if you like 3 times 4 and then multiply by 2, you can go right ahead and do that. Anyways, in this case, we're going to have 2 times 3 is 6, times 4 is 24, or 3 times 4 is 12, times 2 is 24, 24 something, 24, and then we have to make sure we get our units here, and it's going to be 24 centimeters cubed, which is centimeters with a little exponent 3. Alright, with a cube, we could use length times width times height, right? 5 times 5 times 5. We can also, and this is going to be the one that you should get used to seeing as well, volume is equal to side cubed. And all that's going to mean is volume equals 5 centimeters. We pop that in brackets. Cubed is a funny little mathematical sign. We'll talk lots more about it in grade 9 math. But it means we multiply by itself 3 times. So 5 times 5 times 5. Right, so 5 centimeters times 5 centimeters. That does not look like a multiplication sign. Still doesn't. Times 5 centimeters. And 5 times 5 is 25, times 5 is 125. So volume here equals 125 centimeters cubed. Now, what you should realize, I hope, is that these two are not to scale, because it looks like this one's just barely bigger than this one. In reality, there's a pretty big difference in size. Alright, so that's that one. Let's move on. You need to know these formulas. Say that again. You need to know these formulas and be able to use them. Moving on. You need to know what everything in the formula means. Formula to determine the volume of a right triangular prism. Alright, so volume is equal to 1/2. Now we got to be careful here. Normally with a triangle, we'd say, oh, base times height. So I'm going to go base times height, and you can use this one, and then times a big H, which is the height of the whole thing. Does that make sense? BHH. I've heard it base times length times height. I've heard it just A times B times H, where A or B is the base, A is the height of the triangle. I'm really not super going to get bent out of shape about which formula you use, but it needs to distinguish between the H, as the little h here is the height of my triangle, big H is the height of the whole prism. Okay, so in this case, V is equal to 1/2 times, alright, base of my triangle, it tells me down here is 3 meters. And put that in brackets. Terrible brackets. Height of the triangle, 2.6 meters. And the height of the whole prism is 9 meters. Alright, this one a little bit tougher to do in my head, so I'm going to use a calculator. First thing I guess we have to remember, how do we change that 1/2 into a fraction? No, the 1/2 is a fraction. Let's turn it into a decimal instead. And we're going to have 0.5. Right, 1 divided by 2 gives me 0.5. Also, that is one you should just know, that 1/2 is 0.5. So 0.5 times 3 times 2.6 times 9, and we get 35.1. .1 meters cubed. Initially, when you look at that, you go, oh, that looks really big, or that looks like it's small in terms of the numbers, but we've got this half in here too. That's what's giving us a little bit of grief. So that's that one there. All right, let's take a look here at our next one. All right, here's a show you know. All right, so what I want you to do here is find me the volume. Now, remember when you're finding the height, if you want, of the triangle, that's going to be perpendicular to the base. So if you think back to like grade 6 math when you studied perpendicular lines, perpendicular means it's at right angles. So for this particular one, I don't care which one you use. 5 could be the base, which means that 9 would be the height of the triangle. 9 could be the base, and the height could be 5. Either of those work. Alright, so give that a try. Let's pause it, please, and then give it a try. Alright, so to show your work here, equals 1/2 BH, big H. Equals 1/2 times, not 2, there we go. I'm going to use this as our base, 9 millimeters. Oh, sorry, and 5 millimeters here is going to be my height of my triangle. times the big H. The height of the prism is 8 millimeters. These look like slightly nicer numbers. I might be able to do this in my head, but calculator's going to be quicker, and you're allowed to use one of those. So 0.5 times 9 times 5 times 8. Volume is 180 millimeters cubed. Right. Moving on then. Katie opened up a new box of oat crunchies, and she noticed that the box was only 5/6 full. So we've talked about multiplying things already. How much space was empty? So if 5/6 is full, this is a little bit of a problem solving bit. That means that 1/6 is not full, or 1/6 is empty. So what we're going to have to first of all do, if we want to know how much space, that's asking for volume. And so we're going to have to do a little bit of a volume calculation. So let's first of all find out what is, ooh, that didn't work out well. What is the volume of this box? And formula for volume of a right rectangular prism, which this is, volume equals length times width times height. Volume equals my length, and it doesn't matter which you put in where. I'm going to go with 8 being my length. 8 centimeters. Oh. Times my width is 18 centimeters. Times my height is 30 centimeters. You could hear the bell at school, you can just feel like you're here still. Okay, again, calculators here. 8 times 18 times 30 equals 4,320. Am I done at this point? The answer is no, I am not. That would be if the box was full. There is that much oat crunchies in there. But what we have to do is we need to actually find out what 1/6 of that is. Thinking back to fractions, 1/6 of that is going to be multiplied by, oops, sorry, empty equals the volume times 1/6. Okay, so the empty is going to be this number here, 4,320. Uh-oh, I made a mistake here. What did I not do? Centimeters cubed. 4,320 centimeters cubed. I'm going to multiply that by 1/6. Which means we're essentially going to go 4,320 times 1 and then divide that answer by 6. Oops. Alright, 4,320 divided by 6 is going to be 720 cubic centimeters are not full of oat crunchies. Right, moving along. Mr. Chin bought a box of small building blocks for his 4 children. He gave an equal number of them to an equal number to each of them. What volume of blocks will each child get? It would appear Mr. Chin is a math teacher because everybody else would not be concerned with the volume of blocks their kids are getting. However, maybe even a math teacher doesn't care terribly much if they're getting exactly the same amount. But we do have a question to do here. So let's take a look here. We have to use some context clues looking at the picture, and if we look carefully at the picture, we should see that these blocks are stacked 4 tall. Does that matter though? No, it doesn't, because we're given dimensions here. And so we're going to find out dimensions in cubic centimeters. And then, how many kids does he have? Well, he has 4. So he's going to divide those by 4. All right. Your turn. Give this a try. I will be popping an answer only, not the solution. We can talk about solution in class, but I'm going to pop the answer only up here in a moment. So go ahead and work through that. Pause if you need to. Okay, I'm going to put the answer up in just a moment, so pause. Okay, that means pause. All right, so our answer is going to be each child gets 4,800 centimeters cubed blocks. Which seems like a lot, but it's a fairly big box that he's got there. All right. So key ideas here, we need to get these down. Volume of right triangular prisms can be determined using the formula V is equal to 1/2 B H H. And the volume of a right... Oh, change something here for me, please. They both say triangular. One of them needs to say rectangular. So let's make the second one say rectangular. I can change it on mine. That is not going to change it on yours. So you have to write this in. Rectangular. There we go. I apologize for that. And volume equals length times width times height. Which then takes you to your assignments. Have fun.